Hey, what's up, smokers? It's Drago1 here, and today we're going to be taking a look at DecTalk singing. Now, this is a video I've been meaning to make for the past 4 years. Ever since I figured out how exactly to do DecTalk singing, I've been waiting. Oh God, I've been waiting to get a video out for this. And what I've noticed is I don't think there's any other video out there that really goes in depth of how to actually get DecTalk singing. I know there's some documentation out there somewhere, but nobody really sits down and says, okay, this is what's going on. A lot of times it's copy pasta from, because somebody will type in DecTalk singing and they'll copy pasta from what's left over from the DecTalk, original DecTalk site, official, and there's this class site. So I have a bunch of files that I'm linking in the description right now. You can go check it out right now. The whole DecTalk package that basically teaches you how to make a song with DecTalk, and I will include this DT demo because this is just a demo. This is not actual commercial software, so this is not piracy going on. The limitation to the demo is that you cannot export to a WAV file, but that's okay because you can use the analog hole to record playback of.
This is a demonstration of DecTalk.
The voice, so you can use stereo mix, you can use virtual audio cables if you don't have stereo mix, or you can just plug the microphone port into the headphone port and pray it doesn't get distorted. So what I'm going to do today is I'm going to load up a couple of files that I have written myself.
Cheer up, sleepy. Oh, what can it mean? To a daydream believer and a homecoming dream.
Okay, for those of you who are not familiar with the song, that was the chorus to Daydream Believer by the Monkees. Now, I wrote this myself. Well, not the original song, obviously, but this phoneme data for singing. Okay, so first of all, this command here sets DecTalk to read phoneme data. See, these right here are phonemes. They're not words. They're not processed as words. They're processed as the individual phonemes. So for this is two phonemes actually. This is CH, which is the ch of cheer, and IY, which is ear. So let me show you. Okay, so this PDF right here is going to be included in the description if you want to take a look at it. You're going to be referencing this a lot if you're going to make your own songs. First of all, we have two phonemes on this first note here. The CH sound, which is, I don't even know if it's on here. I don't believe that, here we go. CH is the ch in chin. So it'll first sound like ch. And then IY is right here, which is the same sound as the E in beat. So it's an E sound. So ch, which is the same as the ch in chin, and IY, which is E, it makes chi, not cheer, just chi. So then that goes on to the actual pitch and duration information. This first number is the length of the note in milliseconds. The second number is the note number. That's where this comes in handy. So there's only so many note numbers. The DecTalk only has a certain range. You can bypass this by using, instead of the note numbers, you can actually use a specific frequency in place of the note number, and that will allow you to reach supersonic frequencies, but it also removes the vibrato that DecTalk actually gives the voice, which is what makes it sound really, really cool, in my opinion, and I'm assuming you as well, since you're actually looking into doing this. So basically, that sounds a little bit daunting. And it is, because this is where the real time-consuming stuff comes into play, because the other thing you have to do is you have to convert a quarter note at a certain beats per minute into the proper length of the note. So I don't actually remember what the beats per minute is for this song, but let's try and find it. Since the first note was probably a half note, I'm not quite sure. Okay, the first note was a quarter note, so let's find 385, so that would be 156 beats per minute for this song. Assuming the first note is a quarter note, according to this chart, it would be roughly 156 beats per minute. There's an app from the App Store called Tap the Beat Free. I don't know if it's still on there. It's a very simple, old-looking app, monochrome app, that you can plug in the exact beats per minute, and it'll give you the length of a quarter note at that beats per minute. It'll give you the length of a dotted quarter, a whole dotted half, stuff like that. And so that's what made programming this a lot easier. So we have an entire little sequence right here, and it doesn't end until there's the end bracket and then the period. Period is very important, or I don't think the thing will play back. So if I get rid of the period, oh, it'll still do it. It depends on what software you're using, what hardware you're using. I program most of this stuff on actual DecTalk hardware, and if you don't put the stuff in there just right, it'll say command error and phoneme, and you're going to get very pissed because you have to load in the song. I'll get to a hardware overview of my DecTalk hardware, but this is just a software DecTalk demonstration tutorial to give you an idea of what it actually takes to write a song. So what you'd have to do is you'd probably have to transcribe this. I did the notes in separate software. Like I was using GarageBand to transcribe all the notes in the singing sequence. So every single one of these notes. So this would really be MIDI data, and so I then figured out which each of the notes were. I mean, this would really help if you had sheet music for this song. But for me, I didn't, so I had to transcribe it note for note in GarageBand and figure out what the beats per minute was using... there's different ways you can get beats per minute. You can use software. You can use Tap the Beat Free. Not always does it line up. So other things to know about the underscores, those are pauses. And then after an underscore, you'll have the pause length in milliseconds. So this is 720 milliseconds. So there is a one major caveat to doing the phonemes this way. And that is that when you put two phonemes together, like this, and then you give them a duration, and you give them a note number, what will happen is that it takes a certain amount of time for DecTalk to process a consonant, whereas a vowel, it instantaneously reaches that note, and it will last for exactly the duration specified. This was the case when I did my Linkin Park DecTalk. Okay, so here in this situation we have only vowel sounds, just the ah vowel sound, which is like ba. It's just an ah sound. So when I play it back, it won't play back for me because okay, so what's going on there is this will line up perfectly with MIDI. Like this, I didn't have to pitch or time correct any of this. This fits perfectly with the actual song. This can be superimposed over it, and that's what I did in that video. So that worked out pretty well. However, when I tried to line up other songs, so here you'll see something different, a way I managed to circumvent that caveat, and that is to give a specific amount of time to just the consonant. In this case, 90. Now, 90 is a fraction of the actual if you add 90 to 124, you get the length of that note at that beats per minute. So basically, I split up. If this was, say, 214, so I give 90 is the amount of time I'm going to give to just the consonant, and then the actual vowel sound OW, which is boat, O, so go wrong.
Go wrong.
Okay, so that's, and then of course the consonant does not require a note number. This is just a millisecond duration. Now this works a little bit better. When you put this on top of MIDI, it will line up much better, but it's still not perfect. There's something very arbitrary, possibly even random about consonants and how DecTalk handles consonants, and for some reason it is not consistent. So this helps a lot when you give just the consonant a certain amount of time and you subtract it from the overall note time, so that go will only use up 214 milliseconds as opposed to 214 milliseconds plus however long it takes to do the consonant. So that means I had to program the length of the consonants and the length of the vowel in a word. And when it comes to most words in singing, you're pretty much always going to have a vowel in every single word, because if you don't, then it can't really sustain consonants very well. It sounds like if you use an F for a consonant, you just get like white noise. If you use G for a consonant, you just get or something like that. Sometimes it works okay but it sounds really, really computerized, and I mean some people are looking for that sound, but it doesn't sound as good as sustaining a vowel for the main note. Using some of the allophones is okay. Like I believe I used in one of the earlier versions of Daydream Believer.
What can it mean to a daydream believer?
Oh no, that's the fixed one. See, here I'm using instead of because I was using, like, as in the is an orientation, the or what else was I doing? It was one of the allophones, and it was, instead of cheer up, sleep, it was daydream believe. Instead of daydream believe which is easier to sing, it was daydream believe which doesn't sound as good when you're singing it. Oh, it was RR as in bird, perhaps. Possibly. That's an I sound. Oh, whatever. So you basically, if you're going to start programming DecTalk, this is essential that you have this phonetic symbol chart, you have this tone chart, so you know exactly what the notes are for that you can plug in. Because, I mean, DecTalk is doing a lot of the heavy lifting for you. It already knows what note. You don't have to put into the exact frequency. You can, but like I said, that gets rid of vibrato. So if I were to put, so this is 29. 29 is an E. Let's get rid of everything else. So this is just chi.
Chi.
I don't think that had really that much vibrato. Can I undo here? No, not enough. So if I did the same thing, let's make this a little bit longer. No, not that long.
Chi. Command error in phoneme.
Well, it still played it back. That's pretty good.
Chi. Command error in phoneme.
It doesn't sound like there's actually a lot of vibrato to begin with, but you'll see the difference here when I add 329, which is the frequency.
Chi. Chi. Chi.
Well, it sort of works, but you have a little bit of an issue. It sort of like climbs up to the note. So it's not the ideal way to do it. But it might be a good idea if you want to do some sort of pitch bend sort of effects. So, for example, if you wanted to go from 329 to 208. So, but it spends the entire 700 millisecond time to glide down to the note, and by the time it glides all the way down, the note has ended. So there we never had a complete full sustained note, it was only gliding. So if you want to do some gliding, that would be just fine. So right here, for example, we're going to glide up. So this is going to be spent gliding, this is going to be spent sustaining, this is going to be spent gliding, and this is going to be spent sustaining. So, see, it's you could do something cool with it, but I think it's a little bit clumsy, and a lot of that stuff I would have done in my digital audio workstation software. I use Logic Express to do the Tender Lies DecTalk. That was pretty fun, but I had to, like I said, the consonant sound takes up an arbitrary amount of time. I don't understand exactly how it works, and then the vowel sound always takes up as much time as it says it does. So I had to do a little bit of time correction on that. Okay, so the other thing is, which is pretty simple and not really necessary, since you have this sort of bar up here.
Dennis, Frank, Harry,
Since you can already
FGFDG.
You can automatically set the voices, but say you wanted to have a conversation going on. I believe I have a test in here that showcases that. What I'm going to do here is I'm going to change the voice. That's Betty. And this is Paul. And this is Harry. And then there's a bunch more like Ursula, Kit, and some other people. But you could pretty much figure it out by... And I think I have a manual. If I can find the manual, I have a complete DecTalk manual. I can put the manual in the description as well. So you'll see that down there. There's an entire, and it goes really in depth into like the shape of the vocal cords and stuff that it's trying to simulate. This was really fancy technology back in the 80s, and the actual hardware module from the 80s sounds much better than this when it comes to reproducing voices in real time. So let's see if it actually changes the voices here. And I believe this is all should be correct.
What can it mean? To a daydream believer and a homecoming dream.
And there at the end I added a little consonant, because what it sounded like, I mean, I could extend it a little bit to make it be a little bit more noticeable. Usually in music you almost don't hear this, but otherwise it would sound like queen, because this is actually an interesting thing I should describe. This is actually a combination of two words sort of mashed together, which you hear a lot of times in music where they flow from one word to the next, like homecoming queen, for example. So see, this one starts with NK instead of just K, because queen. Usually you'd think it'd be queen. This starts with the last letter from the last word to finish it off. Again, you can split this up between specific consonant lengths and specific vowel lengths, but this is combined just to be a little bit simpler. So that's the reason for that, is so that if this ended, if meh ended with an N, come min, it would sustain the N and not the vowel. See, listen. See, it said queen instead of. meh queen. So it's still a computer singing, so it's not going to be perfect, but you could really tweak it down to the absolute minutia and completely tear your head out and completely lose your mind doing this. I've spent a lot of time doing this, a lot of stress, a lot of frustration trying to get this to work. Except the really hard part is I wasn't lucky. I didn't have this little testing program at the time, and thanks to this guy, I don't actually have his name here right now, but this YouTuber right here, I'm going to put his link in the description for a thank you, sent me this directly via PM, and I haven't had a chance to actually make a video about it. And probably by now, I haven't looked on YouTube, there's probably other people who have made this, that have demonstrated this. A big thing that has sort of brought DecTalk back has been MoonBase Alpha. And MoonBase Alpha, or Unreal Engine in general, has a built-in software DecTalk module much like this. And if you're playing a game like I think Viscera Cleanup the Tail has it, Sanctum 2 has it turned on, and of course MoonBase Alpha has their speech text-to-speech module turned on. It is a DecTalk based speech module, and it will accept all of these commands you see here today. So you can use your DT demo software, you can write up a song, test it out, copy it, paste it in the game, and then just troll people, I guess, because a lot of people think the voices are annoying and not very good sounding.
Hey Jude, don't make it bad. Take a sad song and make it better. Remember to turn to your heart, then you can start to make it better.
So this isn't a perfect rendition. You can hear what the ers sound like instead of the ahs. It makes it sound a little bit more like a computer, I guess. And then if you want to hear it with Paul's voice,
hey Jude,
which I think is a little bit more clear.
Make it bad. Take a sad song and make it better. Remember to turn to your heart, then you can start to make it better.
And of course, you can use any of these voices if you want, and use the command to set a voice in there when you want it. And then there's the default thing that tells you this right here. It can dial telephone numbers. It can play back sine wave tones. If you want to implement that into a song, for example. If you wanted to have a purely DecTalk generated song, you could do it like that. Although the tones themselves make you want to, and you can play back wave files, which sort of defeats the purpose, since you can play back a wave file with anything. Let me get rid of these. But they're a little bit ear piercing.
Dial telephone numbers or generate tones.
Yeah, my ears, they're gone now, and I'm probably going to have to edit that in post to make sure that your ears don't die. Okay, so there's one more PDF I need to show you, and that is the one that sort of brings this all together. This is taken off of a website, and I'm mirroring it here in PDF form, so this isn't lost. Like if their site goes down for whatever reason, it'll still be here. But you can of course go to the original website and get it. And this basically tells you how to sing Happy Birthday. And so this is the first thing that usually comes up when you Google DecTalk singing. And people just copy this out, they paste it in Sanctum or MoonBase Alpha, and then they sort of just run with it. Not trying to sound hipster or anything, but I was into the whole DecTalk thing before MoonBase Alpha hit, and when MoonBase Alpha did hit, I was like, ah, crap. Now every time I'm going to try and make a song with DecTalk singing in it, someone's going to just think, oh, it's MoonBase Alpha, use MoonBase Alpha to do it. And I'm like, oh, God. When I'm actually using a real hardware module. So, in the coming videos, we're going to have I'm going to show my actual real DecTalk card in its dedicated text-to-speech machine. I'm going to show you how the actual card sounds in a software overview, so there's going to be multiple videos after this one. And that'll sort of wrap up the whole DecTalk series. So this sort of pulls it all together. These are links to the other things, the phonemes. There's some song assignments for you to actually write your own song. Like it's a school website, so it's supposed to have that there for learning how to write a song with DecTalk. I mean, it really does feel like an assignment because it's really daunting, because you have to know your vowels, got to know your consonants, you need to know your note numbers for what the right note, and then you have to make sure it's within the right time. There is no built-in beats per minute within DecTalk whatsoever. Basically, the only thing that keeps the song together is that all the notes are the right length, so that the song starts at the right time and will hopefully end at the right time, assuming that all the notes and rests are exact to the song if you want to do a perfect transcription, which is almost completely impossible without tearing some of your skin off. So yeah, there's no reason to order the DecTalk demo. Like I said, you can just use the analog hole, point a microphone at the speaker if you're that desperate. There's other things you can do with it, but this basically gives people all the information they need to know on how to get started with DecTalk singing. You have to figure out the rest. It really helps if you have some sort of musical background, so you understand what a quarter note is, what beats per minute are, what all this is, because it takes a lot of patience to do this, to use a lot of math to figure this out if you don't have an app that does it for you. A lot of memorization, or a lot of looking at the sheet. I'll add some of my custom phoneme files that you saw here today, so you can play around with them. And yeah, that's pretty much it. Thanks for watching. If you were able to sit your way through all this, if you're curious as to what's going on with DecTalk, I've been wanting to make this video for a long time because there's been a lack of just clear-cut examples of how to actually make the singing work. And like I said, if you really don't even want to download the DecTalk demo, you can get MoonBase Alpha and test all this stuff out in there. It really sucks to do it in the chat of MoonBase Alpha, and I really don't think the built-in UDK DecTalk module is that good at all. It sounds probably a little bit worse than this. The hardware module is the only way to go, in my opinion. I don't want to say how much I spent on the module, but it wasn't exactly cheap. They're not getting any cheaper on eBay. That's where I got it, on eBay. They're going up $500, $500 now. So I'm glad I got it when I did, let's just say. So yeah, that's all I can say. Not too much more. The next video coming out going to be something that has to do with the DecTalk machine, so you can see what an actual dedicated DecTalk system would look like, how it would function, and stuff like that. And then we'll have a future video on the software. So thanks so much for watching through all this, and have a nice day.